We talk a lot about harmonic distortion and transient distortion, but did you know SoundCheck also offers non-coherent distortion measurements? In fact, I believe we were the first audio measurement company to include this option. Non-coherent distortion is a broadband distortion metric that includes harmonic and intermodulation distortion, as well as noise. It offers better correlation to perception than harmonic or intermodulation distortion alone, and it can be used with real-world test signals such as speech and music, as long as there is enough energy in the frequency range of interest. Otherwise, you might just be measuring background noise. I usually make these measurements in the near field to reduce background noise by placing the microphone close to the loudspeaker. This is particularly useful for the many modern devices that feature DSP that treats pure tones as noise and tries to filter them out. Non-coherent distortion is a normalized cross-correlation measurement that determines the degree to which the system output is linearly related to the system input. There is a lot of complex math behind this. If you want to know more about that, you can read our 2006 AES paper. Here I'm just going to show you a quick demonstration. Configuring non-coherent distortion in SoundCheck is a simple checkbox in the transfer function analysis editor. I have a good speaker and a speaker that exhibits some fairly significant distortion. Let's look at the good speaker first. I'm going to play a short excerpt of Bird on a Wire at 90 dB SPL by Jennifer Warnes. This song is widely used as a test track as it has good dynamic range.
Like a knife from an old-fashioned book, I have saved all my ribbons for thee.
Now I'm going to play the same song on a speaker that I know shows some fairly heavy distortion.
Like a knife from an old-fashioned book, I have saved all my ribbons for thee.
Now looking at these results, you can see the non-coherent distortion is considerably higher than the good unit, especially at low frequencies. You can see non-coherent distortion in percent per square root hertz versus frequency, also known as spectral density. Since non-coherent distortion uses a broadband test signal for measurement, there is no direct correlation to harmonic or intermodulation distortion in percent. Typically, the distortion level appears much lower than harmonic or intermodulation distortion because the test signal energy is spread out over the entire frequency range and not a single frequency for measuring harmonic distortion. So that's it. Non-coherent distortion offers a way of measuring transducers with real-world test signals that correlates well to listener perception. To learn more, check out our AES papers on the subject or download our free test sequence for non-coherent distortion measurements.